Let's read the question. Evaluate integration of 2 cos x plus 3 sin x by 4 cos x plus 5 sin x dx. We have a rule where we need to follow and solve this particular question. So the rule I'll write first. That is, numerator is equal to a into d by dx of denominator plus b into denominator. So wherever numerator is there we need to submit this numerator, and wherever denominator was there, that where we'll just submit denominator. So let's do this. So numerator we have to write 2 cos x plus 3 sin x equal to a into d by dx of denominator, which is 4 cos x plus 5 sin x, right, plus b into denominator is 4 cos x plus 5 sin x. Okay, so now here d by dx is there, so we just have to derive this. So let's do this. So a into d by dx of we just have to solve only the x term, so 4 is out, so d by dx of cos x plus 5 out, d by dx of sin x. So we were deriving cos x and sin x here. Of course a is the term for both of the variables. Okay, so and this term is as it is. I'm just writing this as it is. So let's derive this part. A into this is 4 d by dx of cos x is nothing but that is sin x. Okay, minus sin x it was. This is 5 into d by dx of sin x is cos x. So these both of the things I'll write 4 cos x plus 5 sin x. So these formulas I'll write here. D by dx of cos x in the sense that is minus sin x. Okay, we need to remember this. Other one is d by dx of sin x, that is nothing but cos x. Okay, so these are the two formulas which we have used over here. Alright, so now I can write this as a into minus 4 sin x plus 5 cos x. Okay, plus b into 4 cos x plus 5 sin x. So this is the equation which we got. We'll write the left hand part also. 2 cos x plus 3 sin x. Okay, so this is the equation which we got. In this particular equation, whatever we got, we'll just say this is equation number 1. Okay, so now we'll compare the left hand side and right hand side coefficients of sin x and cos x, then we'll solve so that we can get this a and b values in this particular equation, where we can further solve this particular question. So in order to get this, we'll use partial fractions and we'll solve this. So I can do here, I'll just submit this a inside first. So I can write 2 cos x plus 3 sin x, that is minus 4a sin x plus 5a cos x, here plus 4b cos x plus 5b sin x. Now let's use partial fractions when we'll just solve this particular equation further, where we can get a and b values. Further, we'll compare the coefficient of cos x on left and right hand sides and sin x coefficient on left hand side and right hand side. Alright, so we'll do that separately. So this is a method which is from partial fractions. Okay, I can write here comparing coefficients of sin x. Okay, here the sin x coefficient is 3, and right hand side the sin x is minus 4a plus 5b. Okay, if I write this in sequence, minus 4a plus 5b equal to 3. Let's say this is equation number 2. Now I'll compare the coefficients of cos x. Comparing coefficients of cos x. Okay, so what is the cos x coefficient here? In left hand side was 2, right hand side that is 5a plus 4b. Writing in sequence, 5a plus 4b equal to 2. Let's say this is equation number 3. Now we'll solve equation number 2 and 3. So I can write here solving 2 and 3 equations. Okay, so what is the second equation? Minus 4a plus 5b equal to 3, and this is 5a plus 4b equal to 2. So none of these values, either a or b, were equal to one to other. So what we do is that this equation will multiply with 5, and this equation will multiply with 4. And let's see what do we get. So this is 5 into 4, which is 20. So I can write minus 20a plus 5 5 is a 25b, 5 3 is a 15, 5 4 is a 20a, and this is 4 4 is a 16b, 4 2 is a 8. So now these both get cancelled. At 25 plus 16, that is nothing but how much? 5 plus 6, which is 11. 2 plus 1 3, 4 41b equal to, this is 15 plus 8, which is 23. So we can get here the b value as 23 by 41. Alright, so 23 by 41 is the b value which we got. Now we'll submit this b value in equation so that we can get a value also. Alright, so let's do this. So I can write here submit b equal to 23 by 41 in, suppose I'll just submit this value in equation number 2. Okay, so what is second equation? 4a plus 5b equal to 3. So what is b value here? I can write here minus 4a plus 5 into b is what? 23 by 41 equal to 3. Okay, so I can get this as minus 4a plus, this is 23 into 5. If you just multiply 5 3s, it was 15, 5 2s 10, and that borrowed 11 by 41 as it is equal to 3. Sending this 115 by 41 to other side, we'll see what do we get. Minus 4a equal to 3 minus 115 by 41. So now 41 into 3, that we need to multiply. So 3 1 3, 4 3s, which is 12, minus 115 by 41. So 123 minus 115, where that will be getting as minus 4a, and this is 8 by 41. Cancelling these 4 1s and 4 2s, so a value will be getting as minus 2 by 41. Alright, so finally we got a value as minus 2 by 41, and b value which we got is 23 by 41. Okay, this a and b, both of the values, will just submit in equation number 1. In this particular equation we'll just submit a and b, and we'll try to solve this question furthermore. So before that, first I'll write the equation number 1, that is 2 cos x plus 3 sin x equal to a into minus 4 sin x plus 5 cos x plus b into 4 cos x plus 5 sin x. Okay, let's submit this a value, which is minus 2 by 41. So this is minus 4 sin x plus 5 cos x plus, what is b value which we got, which is 23 by 41 we got. Okay, so this is the equation after submitting a and b values. So now here the entire equation will just divide with the given denominator. Okay, so this is the given denominator for cos x plus 5 sin x. So then we can solve this question furthermore. So I can write here 2 cos x plus 3 sin x divided by, what we are getting this as 4 cos x plus 5 sin x, that is equal to minus 2 by 41 integration of minus 4 sin x plus 5 cos x by 4 cos x plus 5 sin x dx, that plus 23 by 41 integration of 4 cos x plus 5 sin x by 4 cos x plus 5 sin x dx. Okay, so now this particular one is in particular formula. I'll write here integration of f dash of x by f of x, that is nothing but log of, here we need to write dx also, that is log of f of x plus c. Okay, so this is the formula which we used. F dash of x is nothing but the above part we already derived, so we are saying this as f dash of x. You can check above, we derived it, so we got this one after deriving, so we'll say this is f dash of x, and this is not derived, we just wrote from the question which is f of x, so we can resemble this particular formula here. This is f dash of x, this is f of x, which is giving log f of x. Okay, when it comes to this and this both are same, so we can just cancel, nothing but integration of 1 is remained, right? If both of them are getting cancelled, only 1 is remained. Integration of 1 is nothing but that is x. Okay, so let's submit this both of the formulas here, that gives us answer. So I can write 2 cos x plus 3 sin x by, this is 4 cos x plus 5 sin x, that is equal to minus 2 by 41 integration. This we are applying the formula, this particular formula, so we were getting the answer log f of x is nothing but this denominator, right? That is 4 cos x plus 5 sin x. Okay, now this we got. Now this part was over and this part is plus 23 by 41. Integration of 1 is nothing but it is just x. Okay, of course after solving we have to write plus c. Alright, I hope this is very clear. This is all about this particular question. We'll just go through one more time clearly where we'll get complete clarity. So here is a given question. We need to apply this particular formula in the place of denominator and numerator. We'll just submit that. Here d by dx of denominator, we just derive this. This is what we have taken just now in the formula at the end. Okay, after deriving we got this particular equation where in order to solve this a and b values we were using partial fraction method, and here we applied partial fractions and we got a and b values. Once we got these a and b values, we are submitting that a and b values in this equation number 1. Okay, this equation number 1, once we submitted this a and b values, we were using this particular formula f dash of x by f of x, nothing but log f of x. So this is f of x, this is f dash of x. Alright, so as I just said before, this is a derived part, nothing but f dash of x. So we submitted, we got this particular one, and here the formula, these both of them are getting cancelled, only one is remain, integration of 1 is nothing but x. So we have applied here. So this is the final answer which we got. I hope this is very clear to you.